Hello viewers, welcome to Big Boy Physics. In this video, we'll be learning about application of integrals. In last lecture, we learned about integrals and the basic formulas, what is basically the meaning of an integration. And in this video, we'll be applying this integration in various real life problems. Okay, so let's get started. And our first problem is motion in 1D. We know that for a motion in 1D, we consider a straight line on which a particle is lying. Initially, it is at x is equals to x naught, and finally, it is at x is equals to x. Okay. Now, when it's at x equals to x, suppose the velocity is given as velocity as a function of time. Okay. Now, in a dt interval, let us consider that this particle moves to x plus dx. So, as I discussed in the previous lecture, that when a particle moves by dt, then the distance will be v into t into dt, just like the way we cut horizontal or vertical bars to find the area of a curve. The same way we'll be denoting the displacement of the particle. So this is the infinitesimally small displacement, which is equals to velocity as a function of time into dt. Now, if you want to find the total displacement, that is the net displacement, so you will be integrating it from initial time from which you are starting the stopwatch to final time tf, and the displacement from x naught to x. This way we will be finding the net displacement of the particle and the final position of the particle on the x-axis or the abscissa of the particle. So this is the method in which we can find the final displacement of the particle. Okay. Now there will be some terms like acceleration. We know that acceleration is equals to dv by dt. For motion in 1D, we consider dvx by dt, or by default we write only v, right? So I can say dvx is equals to a dt. Now there may be a case that acceleration is variable. In that case, we have to put an integration from initial velocity to final velocity, and time is from 0 to t. This is way we can find the velocity of the particle as a function of time. Okay. Now in your ninth standard, you might have learned about motion of particle in uniform acceleration. What we consider in that is that for 1D motion, dv by dt is equals to a. So I can say that dv is equals to a dt. Now integrating it, since a is a constant, you can write it as a into integration of dt from 0 to t, and velocity is from v naught to v, where v naught is the initial velocity. So I can say v is equals to v naught plus at, right? So that's the answer. That is the first equation of motion. Second will be, what will be the displacement? So I can say dx by dt is equals to v naught plus at. Now multiplying with dt and integrating it, you will get the final displacement. X is equals to v naught t plus at square by 2, right? Considering the initial displacement to be 0 and final x coordinate to be x, and initial time to be 0 and final time to be t. Okay, so that's the method we'll be employing for the second part. Now third equation is a little bit tricky, I'd rather say. That is dv by dt is equals to a, and you have to prove that v square is equals to v naught square plus 2as. It is written as u square plus 2as, but here we'll be employing x because displacement is x coordinate itself. So instead of s, I am writing it x. So I can say that dv by dx into dx by dt is equals to a. This is a method, that is we are using the chain rule of differentiation. Now dx by dt can be written as v. So I can say that v dv is equals to a dx. Now integrating it back, we'll get it to be v square minus v naught square by 2 is equals to ax. From here we'll get v square is equals to v naught square plus 2ax. So that's the third equation of motion. So I just showed you how to apply integration in 1D motion. Now coming to a question, it's a simple question. There is a person who drives his car in a straight highway at t is equals to 0. Just listen carefully. At t is equals to 0, person is moving with velocity is equals to 10 meter per second. I am writing all the necessary data for you on the screen, and it's also saying that the person passes a signpost at x is equals to 50. At x equal to 50, person passes a signpost. It's also said that the acceleration of the person as a function of time is given as 2 meter per second square minus 1 by 10 t. Right? Now you have to derive the position and the velocity as a function of time. The question is velocity as a function of time and position as a function of time. Right? So how can you find the velocity as a function of time? Velocity as a function of time will be initial velocity plus integral of a dt, and time is from 0 to t. You will get it to be somewhat 10 plus 2t minus t square by 20. Since it's a definite integration, so it will be just like t square by 20, and because it will be t square by 2 and into 1 by 10 will come out to be t square by 20. Okay, so that's the first part. Second part you can just do the same. Now for second part it might have not said properly, the statement given is in proper way. So at t is equals to 0 it passes a signpost which is at x equals to 50. Now x as a function of t is a homework for you. Now indirectly I taught you about definite integration through application of integrals. In definite integration, what we do is that we put some limits like this 0 to t. Now, if I do this v as a function of t indefinitely, how would I do that? V as a function of t is equals to integral a dt plus c, which I'll get it to be 2t minus t square by 20 plus c. Now at t is equals to 0, v is equals to 10, so I can say c is equals to 10. Hence, just substitute c is equals to 10, you will get the answer. But instead of considering this c, what we do is that we integrate it, putting the limits from 0 to t. Hence, we'll get some value like this, and we'll put the limits outside as 0 to t, and this velocity will come out initially v naught to final v, and v naught is given as 10 meter per second as per the question. So time is equals to when time is equals to t, then the value will be 2t minus t square by 20. When time is equals to 0, this approaches 0. Hence, you'll get v minus 10 is equals to this big expression. And that's the answer to the first part. Now, you might be wondering what is the use of putting 0 or considering some constant, because it will finally come out the simple way. But the thing is that there may be some instances in which the initial time will be given as 1 meter per second, and that point of time velocity is given as 10 meter per second. So that is a kind of bit confusing question then that time. So you have to be skilled regarding using definite integration. So similarly, you can comment me down the answer for the second part, that is x as a function of time. Okay. Another question for you is suppose the velocity of a particle is given as 2t plus 3t square. You have to find distance traveled from 2 to 3 seconds. Okay, so that's the question. Now we know that distance that ds, I'm representing ds as the distance, is equal to integral of mod v dt. What is the difference between displacement and distance? Displacement actually relates with the final position, whereas distance is a path function. Distance actually depends on the nature of the particle, how it's traveling, whether it's reversing its direction or not. That is what displacement called. Okay, so if this is the case, we'll be putting it as mod 2t plus 3t square integral dt. Now since it's a positive function in 2 to 3 seconds, we can remove the mod. So we'll be doing like this. From 2 to 3 seconds, 2t plus 3t square dt. Just simply integration, you'll be getting it to be t square plus t cube, and the limits are 2 seconds to 3 seconds. Initially putting 3 in this function will get 3 square plus 3 cube, and finally putting 2 will get 2 square minus 2 cube. Hence the answer will come out to be about 24 meters. Okay, I hope you get how to apply integration in kinematics. Now let us do some fun stuffs. Some fun stuffs like what is the volume of a sphere? What is the volume of a sphere? Now consider a set of coordinate axes, and I'm not representing the z-axis. Consider the z-axis to be outward the plane. This is the x-axis, this is the y-axis. And you have this sphere. This is a sphere, not a circle, okay? Okay, let me represent the z-axis, not an issue. Then to find the volume, we consider a small circular disc and then making an angle theta with the vertical. Okay, then what will be the differential volume? You have to first find the differential volume. Before that, you need to find the differential height of this disc. We know that h as a function of theta can be written as r cos theta. So I can say that dh will be negative of r sin theta. Now dv is equals to pi small r. What is smaller? Smaller is the radius of the disc, which is pi small r square into dh, and smaller is r sin theta. You'll get it to be pi r square sin square theta into minus r sin theta d theta. So you'll get it to be pi r cube with a negative sign also, integral sine cube theta d theta. Now, probably I must have said you about multiple angles formula, and you must remember this formula that sine 3 theta is equals to 4 sine theta minus 3 sine cube theta. Sorry, 3 sine theta minus 4 sine cube theta. Okay, okay. So I can say that sine cube theta is equals to 3 sine theta minus sine 3 theta by 4. Now the limits of the integration is actually 0 to 2 pi. So I'll be integrating this to 0 to 2 pi. Okay, well this comes out to be 0, but this sine 3 theta 1, if you evaluate for the sine 3 theta 1, you will get it, well this 1 minute, this will be 0 to pi, apologize. So this will be 0 to pi, because the integration is performed from theta here to till this, right? That is why it will be 0 to pi integral. This integration of sine theta comes out to be 3 into 2 minus sine 3 theta will come out to be negative of cos 3 theta, negative negative plus, so you will get cos 3 theta by 3, and the integration performed from 0 to 3, 0 to pi. Integration of sine theta from 0 to pi comes out to be 2. Okay, so it will come out to be 3 into 2 plus minus 1 by third upon 4. This comes out to be 6. 3 is a 18 minus 2, 16 by 3 into 4, and it will come out to be 4 by third. So this integration actually comes out to be 4 by third. Since we are interested in magnitude, we take a mod. Hence we will get the answer of 4 by third pi r cube. And that's the volume of the sphere. Hence we derive the volume of the sphere. As a homework, you can also derive the surface area of the sphere also. And another interesting result I'd like you all to derive and memorize it is that, suppose this is my sphere and I consider a segment cut out. Okay, suppose this segment has a height of small h, then you have to tell me the area of this, what can I say, kind of a spherical cap. Okay, you'll be surprised to find the result that this area of this spherical cap is found out to be 2 pi r h. Okay, so this comes out to be the area. So that was it about area of application of integrals. To do some more problems, you can also refer to H.C. Verma. You can complete H.C. Verma basic maths portion also. I have completed it almost. There may be one two things which are left, but those are for Olympiads. I will be covering it in later time. So that's it for today. From next day we'll be starting a bit with kinematics. So stay tuned. Have a nice day.